Alright, we're continuing to talk about functions and relations. Today we're going to be talking about how to identify and how to write domain and range. So if you guys would please, right now we're going to go to problem number 2. Alright, take a look at this. It says for a set of points, determine if it is a function and identify the domain and the range. Alright, let's go and make a table, everybody. Let's make a table. Sometimes it's easier to identify stuff when you guys make a table. Alright? So right now, this ordered pair is what? -4 and 5. So it's going to put -4 and a 5. We have 5 and a 6, 0 and a -7, 1 and a 0, 8 and a 9, and we have -2 and a -2. Alright, so if we're trying to figure out if something's a function or not a function, what was one of the clues we talked about yesterday? Look for what?
The x and the z. The x and z and the y.
Okay, look for the input, output, what else?
Input.
And what about? Right, the input can't be the same number and have two different outputs. So basically, x can't repeat. Alright? Do you see any repeating x values? No. So that lets us know that each x value has one y value, so therefore, this is a function. So everybody, this is a function. And why is it a function? Because each x, or each input, right? Each x value has one corresponding y value. Each input has one output. Now, let's talk about the domain. Everybody, these values are the domain. And these values are the range. Okay? So here's how we're going to write the domain. The domain is the set of all the x values. We're going to list them from least to greatest. So what number would you consider to be the least over here? -4. Alright? Then we're going to go to -2. And then 0. And then 1. And then we got 5. Then we have an 8. That's the set of all of your x values. That's the domain. Right, so we're not going to highlight. Remember, all these numbers here represent the what? The domain. All of these. Okay? Now, the next thing we're going to talk about is we're going to list all the range. So this right here, this is considered to be the range of numbers. Right? So what is our range going to be? From least to greatest. What do we got? -7, good. -2, 0, 5, 6, 9. Alright, so there we go. That is the domain and the range. Okay. So when it says, for a set of points, by the way, this would be considered, everybody, this would be considered a discrete function, okay? A discrete function is different than a continuous function. So if all you have is just a set of points, and just points, that's considered to be what? Discrete. But if you have a function, for example, like this is the parent function for all linear functions, and you have a line, or if you say x squared, what kind of function is that considered to be? That's not a discrete function, that's considered to be what? Continuous, which is different than just a bunch of dots on a page. Just because a continuous means it just goes on. It just, like if I were to trace this, I would just be able to keep tracing it forever. Alright, it would never finish. Okay. Alright, next problem. Let's go down here. It says, for a table of data, determine if it is a function. Identify the independent and dependent variable, and state the domain and the range. Right. So what does independent mean? What are we talking about? And dependent. Domain. Range. What value will always be your independent variable? X. So if I said, hey, what is our independent variable, you would say your independent variable is x. And in this particular case, what is x equal to? What is x represented in the table? The domain. But what else? Look at the table. Look at the table and look at what x represents. Seconds. Very good. Go right down to seconds. So it says identify the independent and dependent variable. The independent variable is x, which happens to be seconds. What's the dependent variable? All right. And what is our dependent variable y equal to in this particular case? Temperature. All right. Okay? So the independent variable is x, which is seconds. The dependent variable is y, which is temperature. You can see over here, there's the seconds, right? There's the seconds. There's the temperature. Okay? So does each x value have one corresponding y value? It does, doesn't it? So therefore, what does that mean? That means this is a function. So this is a function. All right? Now we're just going to say, what is the domain and what is the range? All right, so who here is comfortable telling me the domain for least three grades? Go ahead, D1.
2, 4, 6, 8, 10.
All right, 2, 4, 6, 8, who we appreciate, and 10. All right. Dalton, what about temperature? You want to go from least to greatest? Be careful. Oh, he got it. Look at that. Good job. Yeah. 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 Okay. Here you go. So there's your domain. There's your range. And how do we list it from least to greatest? All right. By the way, something you need to know. If you have the same number twice over here in the range, you don't have to list it twice. So if I had, for example, let's say I had a 12 and I had another 0. Well, you put the 12 here, but you wouldn't have to list 0 again. Okay? So in the range, you don't have to list the same number over and over and over again. Okay? Once you list it at once, you're good. We're done with number 3. Now what I'd like you guys to do right now is we're going to look at these two graphs. All right? This right out, this graph right here is to determine if it is a function and identify the domain and the range. Okay? Now, what did we say we could do for pictures? What do we call a certain test we can do to tell if something's a function or not? Not just the origin, no. Linear line, we call it the vertical line test. So right here, let's do the vertical line test. What is the vertical line test? What's the rule? The rule is this. It can only touch the graph how many times? One time. No matter where it goes through. So right here, no matter where I put this one through right here, how many times is it going to touch this line? Once. So what does that mean? That means both of these are functions. Okay? So right now, what I'd like you guys to do is I would like you guys for A, write the word linear. This is actually a type of linear function. And above B, this is a type of quadratic function. Okay? So this is a quadratic function, and this is a linear function. And now we're going to talk about the domain and the range for both of these. When we're trying to figure out what the domain is, you have to ask yourself, what x values are being plotted in a linear function? Now, x values go which direction? They go which direction? Left and right. Alright? Y values go which direction? They go up and down. Okay? So when you guys are looking at this, does this graph ever look like it's ever going to end to the left? Or does it look like it's ever going to go to the right and never end? No. It's going to keep on going, which means all values of x are being plotted, which means all real numbers. So the domain, everybody, is called all real numbers. Okay? All real numbers. And the range is also going to be all going to show you guys how to write this in what's called set notation or set builder notation. Okay? So right now I'm going to write the answer in set builder notation. The domain, I'm going to write it with a range. Here's how you would write it. Say the set, that's the set symbol, of all x values such that x is an element of the real number system. That's how you would say all real numbers as far as x. So I'm going to highlight what this means. Write this down. Set of all x values such that x is an element of the real number system. This would be something good to put into your journal. I'm going to highlight what each part is. When it says the set of all x values such that, that's referring to this part. When it says x is an element of the real number system, that's what this part means. What do you guys think that this little symbol right here means? Elements, correct. Knowing how to read math symbols saves you lots of time and energy of writing. It also saves you confusion when you're looking at the test. If you know what the symbols mean, you know what it's asking. If you don't know what the symbols mean, you don't know what it's asking. So, what is this symbol right here say we're starting? That's the set symbol, okay? So a set has a start, has a start and has a finish. What does the capital R represent? What do you guys think? Any words, what do you think capital R represents? It represents the real number system. That's what the capital R represents. Okay? Here's how you would write the range. What does the range deal with? X's or Y's? Right? The set of all Y values such that Y is an element of the real number system. That's how you would write the range. Okay? Now, you guys probably haven't done set notation. Alright, so that's why I'm teaching it to you. So when you guys see it on a test, you'll know what the symbols mean. So as far as your answer goes, for number 4, where it says, identify the domain and the range, what's your answer for the domain and the range? This is the answer for the domain. This is the answer for the range for this linear function. Okay? If I look at the quadratic function, the domain is the same. The domain is still going to be the set of all x values such that x is an element of the real number system. All the x values going to the left and to the right, that's never ending. Right? All the x values are going left and right. I know it's kind of hard to see, but technically this is still moving to the right, this is still moving to the left. Okay? But it's going up. This is going up to what's called positive infinity. Alright? And over here, x is moving towards positive infinity. Over here, x is moving toward what's called negative infinity. But all numbers are being plotted. But in the range, not all numbers are being plotted. This parabola bottoms out. It gets to a point where it does not get any lower. What's the lowest point that it gets? -4. That lets you know your range. Are the values getting smaller than -4, or are they getting bigger than -4? They're getting bigger. So this is how you would write it. You say the set of all y values such that y is greater than or equal to a -4. Alright? Now if you wanted to finish it off with a, and yes, all y is an element of the real number system, you can finish it off and put it right there in that bracket. Now the only way to get better at math is to practice writing things down. Alright? Don't just watch the math. Make sure you're doing it. Now could you guys, right now, could you guys put this problem in your journal right now with me? We're going to make a graph, okay? I want you guys to make, it doesn't have to be that big. We're going to make a graph that has an x-axis. Alright, there's the x-axis. There's the y-axis. Now this is going to be very, very, very important. I want you guys to put an open circle right here. Do not close it in. Do like an open circle. Alright? And down right here, I'm going to fill it in. Okay? And then I'm going to make a funky looking graph. Alright. Doesn't matter what it looks like. Okay? It could be a straight line connecting it. Alright? But right now, just make a graph with an open and a close. The only thing is, yeah, that's fine. Okay? Just make sure this is your highest point, make sure that's your lowest point. Over here, make sure that's the least point and that's the greatest, because we're going to talk about the domain. Alright, here's what I want you to do. I want you guys to draw an arrow from here right over where that other dot is. And I want you to label that. This is what's called the domain of the graph. And then I want you to draw another arrow going up and down. And from the highest point to the lowest point. That's what's referred to as the range of the graph. Alright, what's this ordered pair right here? What's that ordered pair? What's my x coordinate and y coordinate? What do you guys think? -2, so it goes -2 to the left. And how far does it go up? 3. That's your x, and that's your y coordinate right there, -2, 3. What's your x and y coordinate right over here? How far to the right does it go and how far down? It goes over 1, 2, 3, 4, and it goes down. There we go. So that's a 4, -1. So right now, we're going to write our domain, everybody. All right? Here we go. Domain. What's the biggest number? What's the maximum number that it gets to on this? What's the biggest number? Yeah, that's as far as it goes. Does it go beyond that? No. The maximum number is 4. What's the minimum number for the x values? It goes from what? It goes from a 4 all the way where? -2. You ever see that? It goes from a 4 to a -2. That's the minimum. All the x values are between them. Now this is what you guys need to understand. It's that enclosed circle there, where it's that solid dot. That means equal to. Open, not equal to. Solid means equal to. Open means not equal to. So watch. It's going to be less than or equal to the number 4, but it's just going to be greater than a -2, because it's not including it. So here's your final answer. The set of all x values such that x is greater than -2, but less than or equal to a positive 4. That's your answer for your domain. So go ahead and write that down in your journal. Next thing we're going to talk about the range. We're going to say the set of all y values such that, we need to figure out what is y between. How low does my y value get right in here? What's the smallest number that it gets? -1, yes, -1, right there. That's as low as it goes. How high up does it get? 3. So that's the max. So what's the maximum for the y value? 3. What's the minimum for the y value? -1. Now, is it equal to the -1 right here? Is the y value, when it's enclosed, does that mean it's equal to? Solid dot means yes, it's equal to. Open dot means no, it's not equal to. Alright, so open circle, not equal to. Enclosed in dot means equal to. So your y value is greater than or equal to -1, but it's just less than a 3 because it's not including that number. This is an example I want you guys to have in your journal because you're going to have questions that look exactly like this on your test. And it's going to ask you for either the domain or the range. Now we have 2 problems to do on your paper. We're going to do them together. We're going to do this exact same strategy now on your paper. Alright, so the last thing we're going to do right now, we're going to look at these. We're going to do the exact same thing you just did. I want you to draw an arrow going from here to here, representing the domain. I'll do it in red. And then and we're going to go from here to here, representing the range. We're going to put some numbers here. We're going to write down, put D for domain, put R for range. Now, on the domain, how far left is it going? What's the X value right there? Negative 5. So negative 5. Okay. How far is it going over here? What's the Y value? Oh, not sorry, not Y. What's the X value over here? 7. Good. How low does it go? Where's this cross? Negative 3 squared. Negative 3. And how high up does it get? It's all the way up to a 5. So go and list those. All right. So if I just asked you guys, just in your own words, what are the X values for the domain? What are they between? What numbers are they between? Negative 5 and 7. Now what's the difference between the open circle and that one that sits closed? Well, the one that's,
well,
you're right. You're right. What you said is right as far as it is. That is positive. That is negative. But enclosed means equal to. Open means not equal to. So here's how you write it. X is less than or equal to the 7. So it's less than or equal to the 7, but it's just greater than the negative 5. With that, no, this is not a 1. That's just a bracket. Okay. But open. I'm just going to put that line right there and enclose. So we have a set of all X values such that X is less than or equal to 7 and greater than a negative 5. Now I'm going to write down the range. A set of all Y values such that, what's my smallest Y value? Negative 3, right? What's my greatest Y value? All the way up here.
5.
My greatest Y value is a 5. All of my Y values are between. Now which one is my Y value equal to and which one is it not equal to? Equal to 5, so we'll say it's less than or equal to a 5, but it's just what? It's just greater than a negative 2. And that is your final answer. What is it? Now we just have one more to go. And all the way over here to stop. And all the way up here down to right there. Let's write in some numbers. In red. Where are we at in red? Negative 6. Where are we at over here? 8. So we're from a negative 6 to an 8. All right, where are we at in the Y's? How far down do we go?
0.
Nope, go to 2. Right here. How high up do we go? 8. So here's your final answer for your domain. Domain. Set. All X values such that X is less than or equal to 8, but greater than or equal to a negative 6. Why is it both equal to? Because that's solid, that's solid. Set of all Y values such that Y is less than or equal to my highest number, which is an 8, and greater than or equal to a 2. And why is it equal to? Because it's solid, because that's a solid. Those are your final answers.